Dr. Amy Simon, let's talk about this mission. This is pretty cool, but also kind of been a long time coming here. So let's talk about asteroids to begin with and why it's important to study them.
Absolutely. Asteroids are these small rocky bodies, and they're pretty much the remnants from solar system formation. And so what they are is pristine examples of the building blocks of the planet. So we study them because we want to understand how the Earth and all of our planets were formed.
So let's talk about Bennu, and it's been studied here. 7 years this mission has been going on. So can you take me through the 7 years and what's been going on over that time period?
So OSIRIS-REx launched in 2016, and it took us about 2 years for the spacecraft to basically catch up to the orbit of Bennu. So we had to go back by the Earth before we got there. And once we got there, we got into orbit. We spent about 2 years mapping out the surface in detail down to the smallest little pebbles, as well as studying the composition and figuring out the best place we might get a sample from. But then we spent a long time actually rehearsing and practicing for this sample return because it is a fairly challenging maneuver we were doing. And because of that, we were able to safely pick up our sample. And we left the asteroid in 2020, and it's actually taken us 3 years to catch back up to the Earth at the right point in its orbit.
Okay, so how far away is Bennu?
Bennu is actually a near-Earth asteroid, which is why we wanted to go to it, but it's not necessarily in the same place as Earth at the same time. So we kind of have to orbit around till we catch up to each other.
I read your bio. It seems like you're kind of like the instrument scientist. So I want to know what is on OSIRIS-REx and what's being studied and how you study. I mean, I'm picturing like Armageddon here. Do you have a bunch of people drilling into the asteroid, or how does this work?
We definitely did not touch the asteroid. We have actually several instruments on the spacecraft. One is a camera suite, and that's designed to look from a variety of different distances from up close to really far away. We also have two spectrometers, a visible and infrared spectrometer and a thermal emission spectrometer. And the way they work is that they take the reflected sunlight that's coming back off the surface and they break it down into its components, just like a prism does or a raindrop does to make a rainbow. So we separate the light out. And what happens is that reflected sunlight, when the sunlight hits the surface of Bennu, the different minerals will absorb different wavelengths of light. And that exact pattern is kind of like a fingerprint that tells us what the composition is on the surface. Then the other instrument we had is a LiDAR. And that's exactly what you think it is. It's the same as any other LiDAR you have on Earth or like radar, where we're bouncing a light signal off the surface to figure out the distance. And we did that to be able to map down to literally centimeters on the surface.
Has any information come back yet? Have you seen the images, or is all of this being delivered in a fancy package on Sunday?
We wish. No, all of the information came back pretty much as we were taking it. We would record it and play it back right away. And we needed that information because we had to figure out the safest and best place to take our sample. So we couldn't have actually done our sampling without taking that data and analyzing it on the ground first.
Okay, so how did the sample get taken?
So our sampling actually was a really inventive technique. We did not land on the surface. We did not drill into the surface. We had a sample collection head that acted by barely touching the surface and blowing nitrogen to stir up all that dust and soil and push it into our sample collection head. And all of that happened automatically. We were not in the loop. So the spacecraft had to do that on its own with a lot of practice.
Tell me what's happening on Sunday and where.
Okay, so Sunday is a huge day for us. This is NASA's first asteroid sample return. It's also going to be the biggest sample we've had since the Apollo moon rocks. So that's a big deal.
Wow.
But early on Sunday, the spacecraft will release the sample capsule. It will enter the Earth's atmosphere. It'll slow down on parachutes, and then it's going to land on the desert floor at the Utah Test and Training Range. And our recovery team will go pick it up and put it into a temporary facility. And then the next day it flies to the Johnson Space Center, where the capsule gets opened, everything gets processed and curated, and some of the samples get sent out for analysis, and the rest of it is actually all archived for future experiments that we haven't even thought of.
So can you give me an idea of like how much the sample is, like how much it weighs? I'm trying to picture if it's like this much or if it's massive amounts of rocks and dust.
So our sample is about 9 ounces, a little bit over half a pound, which may not sound like a lot, but that is a huge amount compared to what we've been able to do on other missions. Our sample head was about the size of a tire. So it wasn't huge. But that's actually a lot more than we've ever gotten from an asteroid. So that's actually, for scientists, it's a treasure trove. That's going to be, the gift that keeps on giving for a long time.
Have you been with OSIRIS-REx for the 7 years, for the entire 7 years?
I've actually been involved with OSIRIS-REx since 2009.
Okay.
So yes.
So yes. What are you most excited about? What are you looking forward to?
So coming from the perspective of doing these remote sensing instruments, we saw what was on the surface to the best of our ability without getting up close, but the surface is really dark. So it was hard to see a lot of that chemical makeup. So I'm really excited to see what those samples are made of and see how well it compares to what we saw from orbit.
Is there plans for future missions to asteroids?
There are. We're actually in the middle of what we're calling Asteroid Autumn. Besides our sample return coming back, we have another mission launching in October called Psyche. That's going to a different type of asteroid, a metallic asteroid. And we also have the Lucy mission, which is on its way out to asteroids by Jupiter, but it's going to have a flyby of a small asteroid on November 1st. So we have a whole bunch of asteroid events in the next few months. And our OSIRIS-REx spacecraft itself is also going to be going on to another asteroid.
I know NASA's really good about live streaming everything. So can the general public watch this parachute come down on Sunday?
Absolutely. The best place to see it is actually from the comfort of their own home. You won't be able to see it if you go outside, but NASA will be live streaming the entire event, and people can follow along at www.nasa.gov, or they can follow us on social media, just at NASA. And the live stream will start at 10 a.m. Eastern, 7 a.m. Pacific.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.